Okay, so in this video, I want to explain what the perceptron is, but I'll explain it with an example. I'll explain how a single perceptron can represent other machine learning models as well, like the logistic regression, how they're all similar. So perceptron is basically a very small building unit. It's the building block of every neural net. So when you have a neural net, right, like one, two, three, four, then you have more neural nets, more neurons over here. Every one of these neurons is a perceptron, right? And you can use perceptrons to model a very large number of activation functions and everything. So I just want to explain. I want to first relate how perceptron and how logistic regression can be expressed with a perceptron model. All right. So wait, what is the goal of logistic regression? You have a data point xi and you want to predict its class yi hat, right? That's the basic goal of every logistic regression model. And your yi hat is given by the sigmoid. The sigmoid is a function of w transpose x plus b, right? X is your input, b is some constant, and w is your weight vector. So when you say that you want to train a logistic regression model, training a logistic regression model basically means finding the values of w and b that that are optimized, right? That best optimize the model. Correct? That's what you mean when you want to train a logistic regression model. So I'll write this in a mathematical formula here. It's it's given by sigma I equals 1 to n w transpose xi plus b, right? Where w is your weight vector w1 comma w2 all the way to wd, the d number of dimensions, correct? So how do we model this logistic regression using a perceptron? So look, this is your perceptron, this is the nucleus. You have inputs over here, right? These are inputs. You first perform the summation. Uh, you first perform summation on all of these inputs, then you perform a function. The sum of all of these inputs, you put it into a function, and that's how you get an output from this perceptron. This is how a perceptron is, right? We discussed this. This is how a neuron is in a neural net. So the output here is given by f of sigma I equals 1 to d w transpose xi plus b, right? So this is a perceptron. If I want to model logistic regression using a perceptron, I can do it this way. Let's say I have four inputs: x1, x2, x3, and x4, right? And I give each one of these inputs some weight: w1, w2, w3, w4, right? So the summation will ensure that I have the sum of all of these. So look, if I'm getting x1 with a weight w1, so that is x1 w1, right? And I sum all of them, plus x2 w2 plus x3 w3 plus x4 w4, okay? And I sum it all up, correct? If I apply a function on this, I get an output. This is basically my output, right? This output over here. Now if this function is sigmoid, I've essentially modeled the logistic regression using a perceptron. Now you might ask me, what about this b over here? For this b, what I can do is I can give it another input with a weight b. The value of the input is 1, it's a constant, but I can give this input a weight b, right? And because b has to be optimized, when you're trying to find the optimized logistic regression model, you're basically trying to find the best values of the weight w and this constant b. So because b has to be optimized, it is supposed to be given as a weight to the input, right? So this is how you model a logistic regression using a perceptron model. So basically, the idea over here is that this f, the function from Perceptron, is basically a sigmoid function. And this is exactly the formula for logistic regression, correct? So now let's come to training a neural model. Now, why I'm trying to tell you using weights and this value of beta b is because when you say that you want to train a neural net, the basic idea is that you're just trying to find the best weights w for your neural net. Okay, so this is a very simple model for a neuron, right? This is just one perceptron. When I say deep neural networks, I'll put all of these neurons or all of these perceptrons into layers, okay, one upon the other, one after the other. So we'll discuss that in the next video, but I just want to drive home the point of how you can model different machine learning models that you've studied in statistical machine learning using the perceptron, right? So now I just want to, so now this value of function is what, if I give it sigmoid, I basically model I'll basically model logistic regression using a perceptron. But in reality, the perceptron, when it was first discovered, right, it is the oldest model of a neural network. Okay, so the first perceptron was discovered in 1957, and so the activation function for a perceptron is not sigmoid. Okay, if I have x1, x2, x3, x4, w1, w2, w3, w4, and I have some output O, and this is the function. So f of xi, the function, xi is basically x1, w1 plus x2, w2 plus x3, w3 plus x4, w4. This function is the function for a perceptron, and it's given by 1 if w transpose x plus b is greater than equal to 0, or 0 if w transpose x plus b is less than 0. Okay, this is how you model a perceptron. It's basically a linear function. If you draw the graph, you either have 0 or you have 1, right? It's this rectangle right here. Okay, so that's how a perceptron is. So basically, just changing the activation function over here will give you different results based on what you're trying to model. If I give it the sigmoidal activation function, so this is the active. If my activation function is this linear 1 or 0, then this is how the graph looks. If it's sigmoid, the graph will look like this, right? This is how the activation function of a sigmoid is. It's between 0 and 1. Correct? So that's how you model different models using perceptron. Now, in the next video, I'm going to extend the simple perceptron model to build multi-layered perceptrons, which is what deep neural networks are. Okay, so I'll see you there.